The final thing to discuss today is one-tailed test. And one-tailed test can be both right-tailed and left-tailed. So we will start with right-tailed test. Under right-tailed test, zero hypothesis states that beta 1 is smaller than 0 or equal to 0, and the alternative hypothesis states that beta 1 is greater than 0. Speaking informally, we will use a right-tailed test in order to verify the following hypothesis. Gender has a positive coefficient, which implies that males earn more in comparison to females. So if we manage to reject zero hypothesis under right-tailed test, it will mean that this statement is true. We do not have to calculate t statistics again. It will be the same regardless of the type of test you use. However, what we need to do is to define new critical value. So in order to do this, we have to get back to our table, t-table. We have the same degrees of freedom, 23, but as you remember, the first row is for one-tailed test, and the second one is for two-tailed test. So previously, when we performed two-tailed test and we wanted to have alpha equal to 5%, we used this column. Now, we still have to keep alpha equal to 5%, but now we are performing one-tailed test. That's why we take this column, and our critical value is 1.714. Speaking formally, we can reject zero hypothesis if our t statistics is bigger than the critical value, not calculated, but taken from the table. We can visualize it using t-distribution. So this shaded area is our critical region, is for t bigger than critical value. We can see that t statistics we calculated before is located here in critical region, which means that we have to reject zero hypothesis in favor for the alternative hypothesis. Another way, beta 1 is indeed bigger than 0. And naturally, this test is called right-tailed test because we use only right tail of the t-distribution. Left-tailed test is the opposite. So zero hypothesis of this test states that beta 1 is bigger than 0 or equal to 0, and the alternative hypothesis is that beta 1 is negative or smaller than 0. Again, I would like to underline that instead of 0, you can put any value you use for comparison. We use 0 because this is a typical way to assess statistical significance of the variable. Using left-tailed test, we will be able to verify whether the following statement is true. Gender has a negative coefficient, which implies that males earn less in comparison to females. So, if we manage to reject zero hypothesis under left-tailed test in favor for the alternative hypothesis, then this statement is true. We use the same critical value, but now we take the negative value. So if it was 1.714, now we compare it to the negative 1.714. Speaking formally, we will be able to reject zero hypothesis if t statistics is smaller than this critical value. We can depict those values on t-distribution. So now this is the critical region, like to the left of the negative 1.714 region of rejection. And you can definitely see that our t-statistics calculated based on the value of beta and standard error is here in the region of acceptance. It's easy to see because this is a positive number. Therefore, because 4.93 is bigger than negative 1.714, zero hypothesis cannot be rejected. In other words, we fail to reject zero hypothesis. So we have to stick to the statement that beta 1 is bigger than 0 or equal to 0. So that was it when it comes to the tests. We discussed it because when it comes to post-estimation tests you run in order to see whether your model is good enough, you will use it a lot. However, we will concentrate on this issue in the next videos, therefore there is no need to worry about this in advance. I really hope it was helpful. If you have any questions, please do not hesitate to contact me. In the materials for this lecture, you can find some exercises you can do in order to check whether you understand the topic and you are able to perform a significance test. Yeah, so that was it. Thank you a lot and see you in the next video.